Welcome back, grade 8. In this particular math video, we are going to talk about the exterior angle of triangles. So in our last one, we talked about the interior angles and how all of the angles add up to be 180 degrees. In this video, we're going to deal with angles that extend beyond the triangle itself. And we're going to use a couple of different rules to be able to solve some of these values. So if I have a triangle here, all of these angles are what we would call interior angles. But if I was to extend the line here and I were to have another angle at this particular point, that would be called an exterior angle. And that's what we're going to be working with today. And there are actually two different ways to solve for an exterior angle. One is that we know that whatever this angle is, let's say that's kind of let's say that we know that that's a certain value. This plus this exterior angle makes a straight line, which equals 180 degrees. So one way to solve our exterior angle is to take that particular angle, to take 180 degrees minus, let's say that's those different values, minus angle C in this case, whatever this value is going to be. Another way that we could figure out this exterior angle, though, is that this exterior angle is always going to be the sum of the two opposite angles. So not angle C here, but these two angles added together. So in this case, our exterior angle could also be angle A plus angle B. And those will both give us our exterior angle, and they will both give us the same value. And that's the main part of this entire lesson. And we're going to use information about that with information we've previously gotten from interior angles as well as from parallel lines in order to solve some particular geometry-based questions. So we're going to get into our example questions right now. If you'd like to stick around and listen to that as we step through, especially since they pair perfectly with our try-its, then you're welcome to. If you would prefer to take a look at the example pictures on your own through the PDFs in the lesson, you can do that too as you work through those particular questions. But at this point in time, we're going to move on to our examples. Example 6. In example 6, we are given a particular figure. It says PQR is a straight line, and then we're given triangle QRS. So try-it 6, let's just draw that out here. A straight line, this kind of comes up, and this is here. We have certain things labeled, so we know that this is 48 degrees. And then we have a little square here. Remember that means that this is a right angled triangle. So that means that that's 90 degrees as well. And we're asked to figure out this exterior angle right here. So again, a couple of ways to do it. One of the ways is if this right here is an exterior angle, then the exterior angle is the same as the sum of these two other angles. So this exterior angle is just 48 degrees plus 90 degrees. Which would give us 138 degrees. That's one way we could do it. The other way we could do it is we could say, okay, well, this whole triangle, if these two added together are 138, then that means that this remaining value to finish the triangle must be 52 degrees. And then this together, if that whole thing is 180 minus 52 is 138. Two ways to get to the same place. But that's for example 6. Let's step through example 7. Example 7, we have a bit of a different setup here. We have a parallel line here, comes across, and we have a parallel line here as well. We have 44 degrees up here. We have 78 degrees up here. And we're asked to find this exterior angle. So for this exterior angle, it makes it a little bit trickier. However, if we extend these lines this way and this way, we actually do create for ourselves a little bit of a Z pattern. So if this is 78, then this is also 78 degrees. And the reason why that's important is because this exterior angle then just ends up being the sum of these two other angles. Okay, because whatever this interior angle is going to be doesn't really matter. This is going to be the sum of these two exterior ones. So that's now going to be 44 degrees plus 78 degrees. And when I add those two particular values together, I'm able to figure out that this exterior angle is 122 degrees going across. Again, I could figure this out. I could figure out what this value is going to be. Right, so if this is 122 added together, then to get to 180, this interior angle must be 58 degrees, which means that this as 180 would bring this to 122. There's, again, different ways to go through it, but this I find is probably the easiest. Let's go through example 8. Example 8 gives us a bit of an odd setup here. Let's see if we can draw it out. Okay, so maybe not exactly like the picture, but it'll work for our example. 34 degrees for that angle, 45 degrees for that angle here, 35 for this angle here, and we are asked to figure out the measure of angle AFB. So in this particular example, we're asked to find this angle. And so it gets a little bit trickier here. We don't have parallel lines that we're working with. And so we have to figure out other ways in order to solve this particular question, in order to get the particular angles that we need for this question. And so that's really what we are trying to solve, what we're trying to figure out here. So in our way of attacking this, we start off with triangle BCD, or angle BCD. If we kind of think about this like a triangle, now it's labeled in yours as BCD. If we think about that as a triangle, angle ABE, so this one here, this angle here, angle ABE must be the sum of angle BCE, so this angle, 35 degrees, plus BEC. So we're basically creating this big triangle here, and we're saying that this inside angle has to be the sum of this and this, because it's the exterior angle there. So this, I know it's not what we're solving yet, is 35 degrees plus 34 degrees, which is 69 degrees there. Now, this is what we're solving for, though. If I know this and I know this is 45 degrees, I know this is 69 degrees, I add those together, and that gives me 114 degrees. So if I know that information and I know that triangle has to equal 180, I just take 180 degrees, subtract the 114, and I figure out that my missing angle here, my interior angle, is going to be 66 degrees. So that one took a lot of kind of outside the box thinking in order to figure it out. It had us dealing with this triangle in order to figure out the exterior angle, which was a part of this smaller triangle, so that we could figure out the third missing value, which was the third angle within the triangle. It got a little bit complicated, but when we start thinking outside the box, hopefully that's something that can help. Example 9 gets real complex here, or a lot more complex, as we seek to go through solving for some of these missing values here. So we are given a bit of an odd shape once again. I'm going to do my best to draw it here. Okay, so we have 37 degrees. We have angle X. We have 140 degrees. We have 22 degrees. And that's the information that we have to work with. Actually, with this one here, it's actually a little bit similar to the one here. And we'll get to that in a little bit. But for this one, to start off, we're actually going to draw a bit of an imaginary line through here. And that imaginary line is going to help us to solve some of the rest of this question. So we're essentially making two triangles now as we create this separated line. And we actually separate this then into two parts. So if this is angle D, we're going to say we have D1 now and D2 as a part of this. And if this is angle X, we now have X1 and X2. Okay, so D1 and D2 together equals that 140 degrees, that exterior angle. Okay, now that we know that that is an exterior angle, we can use that information to solve some of the rest. So if, let's just step through kind of the rest here. So in angle ABD, ABD would be this triangle here. We kind of separated off these two triangles. In that triangle, we know that D1 here, this exterior angle, is 37 degrees plus X1. So we know that's the case. That equals D1. If we take a look at the next triangle, ACD, this triangle here, we know that 22 degrees plus X2, so I'm using the opposite angles here, gives me D2. You might be saying, okay, well, where are we going with this? Well, we know that D1 and D2 together equal 180 degrees, or 140 degrees, sorry. So if I bring these two together, that means that 37 degrees plus 22 degrees plus X1 and X2, I'm just going to combine those and say X has to equal 140 degrees. Okay, well now this is something that's solvable. 32 plus 27 gives me 59 degrees plus X equals 140. Bring this to this side and subtract, and I'm able to now figure out that X equals 81 degrees. It took us an awful long time to get there, an awful long way to get there. We had to do a little bit of some more advanced algebra through it, but hopefully you were able to step through. Now, Try It 9 is the same sort of way. So you'll get a chance to do this again in Try It 9, or something very similar as you're solving that particular value. So hopefully this example 6, 7, 8, and 9 help you work through the Try It 6, 7, 8, 9 in your math work.